Right, we're moving on to one of my jobs today, and this is we haven't covered the Harvard base station, so here is a Harvard H404, not the more usual one, which is the H407. This has got the silver grille and the silver sides. I think it's the same. I seem to remember seeing these after the 407s, but with an earlier model number, I've never kind of worked that one out. They did plan another one, but it never happened. I think it had instrument handlers. So I thought this was the rarest thing since sliced bread was invented, but it turns out not at all. It's just me who's only ever seen this one. We've got 3 Harvard 407s lurking, but we've only got 1 Harvard 404. So I did a quick look on eBay. There's currently one for what I think is a giveaway, £67. And there's a 407 currently for a buy it now of $59.99, and I expect that to sell within 30 seconds of publishing this video. So it's the same radio, it's just this is a bit more unusual. That's got some lovely dents in the speaker, but it doesn't matter because you can take the front off, you can take the speaker out, you can undo the grill. It's got some metal tabs which bend back, and you can deal with it, and you can even respray that while it's off the radio. So I thought I'd have a look at closed auctions recently, because unlike the Cybernet 134 base sets like the Harrier CB HQ we use, and the what else? The York 869, that great big thing from Midland 76900. There might be some other bases which I just forget at the moment. So these don't seem to go for much money. So sold for £50, sold for £51, sold for £70. But why has that got a black grille? I'm not sure about that. And then we look at 407s, and just up the page, one had gone for 40 dead. But again, £46, £48. Surely these should be 95 plus. But there you are. So that is what I researched. Now, we did repair this when I bought it about 20 years ago. So we'll go through a service, but it shouldn't be vastly out. So we'll take 1,000,000 screws out. I think when I bought these, probably paid somewhere between £40 and £45 15 and 20 years ago, so the price doesn't seem to have changed. And I say I find that strange, because you won't get a Harrier CBHQ for that. And although this is of course a different board, it's the Cybernet 002F chassis, it's still a competent radio. And if you can get one of those power leads, then you can run it on 12 volts. So high-low power's on the back, as you expect with that, the chassis it uses. Oh, missed that one, didn't I? To be honest, this case top could do with going through our dishwasher. It was probably a bit cleaner when I looked at it, or whoever last looked at it. I can't find the screwdriver we normally go. It's there. So it is the Cybernet 002F chassis, as used in the Mustangs, Harvard 402 MPA, the genuine Amstrad, not the pretend Amstrad. So yeah, you've got a nice mains transformer, you've got a regulated power supply, and things are shrouded, which is nice. Don't know why that's got some solder on it. It hasn't now. Nobody's nicked the ballast resistor, but whether or not that needs upping from the 3-watt one to something else, we'll find out. When I was servicing these 15 and 20 years ago, we weren't checking the VCO on everything, so there are little things which we do now which we didn't then, as time's moved on, etc. So I'll plug in the instruments to this. I don't know where we're going to plug it in power wise, because this bench isn't geared up for mains. But I'm sure we can find a socket. Which does this go into? It's got PA on it as a base station, and if you've got a bit of an office in a warehouse, it can be useful, so it's not as daft as you think. I might just be able to, yeah, there's half an inch to spare. Plugged it in next to the video mixer. Okay, so switch it on. Turn down the volume. Check RF gain and mic gainer to full. Well, that tells us a signal generator somewhere near. We did an experiment changing all the capacitors, you know, on one of these. Well, not on this chassis. I can't even remember which radio it was. Probably Fidelity 2001. And I don't remember it made any difference at all. Now, nearly every part in this chassis is Sanyo. The Sanyo transistors, the Sanyo chips, the Sanyo capacitors, and Sanyo stuff's very reliable, and even 38 years later, we're not having many capacitors fail. And the same on the 134, a lot of stuff in there is Sanyo, but it can make a little difference. But in contrast, the Uniden based sets, there's a lot of capacitor failures now. So there you go. Horses for courses, etc. I think it would be prudent, because we've changed what we do these days, as I said. I think it would be prudent to change the capacitors on the power supply. Not sure if we've got these in stock. And I haven't got a circuit diagram, so it's just a matter of what we find inside. So I think if we had a customer repair in, then I'd be changing that capacitor and the ones in the power supply. Usually, even that one's going to be quite well protected, because unlike putting a radio in a car, you haven't got a changing voltage or a dodgy alternator. And the same applies with a normal home base arrangement where you have a separate power supply. Things can be different. So its own power supply is protecting the radio. So I'd like to see 13.8 volts. I'll tell you what we'll do. We'll run through what it's doing right now before we do anything, and we'll just see what. So I could do with something to rest on. How about the lid? So Harvard H404. So we'll switch picture in picture on, which is hopefully there. It's not in the position I want it. That's the position I want it. Switch to the 3-watt scale of the test set. We're on channel 20 and we'll go for transmit. So it's doing more than 3 watts. It's actually doing 3.1 watts. So deviation is probably correct. Low. So a bit low, 2.1 kilohertz. Frequency. Should be 27,79125. 27,79120. We'll pull that up here and now. It's not going to make, you know, it's so spot on, but just for the thing, will it come up? That's the limit, 23. There's no more adjustment. So in another 30 years time it might need the crystal changing. So let's look at receive. Actually 0.2567, 0.29 microvolts for 12 dB. Cyanide. Look at, I say this is a service set. Well, it was 20 years ago, so it won't be far out. It's not been messed with. So it's very good. So we'll start by looking at this power supply and seeing where we are with it. I'll just go and I'll just take the picture-in-picture off because we don't need that now. Mind you, I'll probably forget to put it back on again when we do need it. So this power supply is adjustable. There's no sign of any capacitor snags, but it might be prudent to change them if we had them. It looks like we did the meter lamp when it was serviced last time. I'd like to know where the power supply output is. That's the input. I think that's the output. So it's 13.5 as it is. So I think we'll bring it up to the industry standard of 13.8. I don't know whether the chassis is something we can clamp to. Yes, it is. So hopefully we can see that without my arm. We hopefully can pop it up to 13.8. There we go. Let's see how that's affected transmit. I won't switch picture-in-picture back on, but it's now 3.2 watts. It's gone up 0.1. I'd like to know what that capacitor is, just for future reference. It's 3,300 microfarads at 35 volts. So I know for a fact we won't have got those. It's something to get in stock, I think, nowadays, because I think these are going to come in for service. Power supply 3,300 at, did I say 35 volts? Yeah. And we've got 47 microfarads at 16 volts. And 10 microfarads. They're standard enough. So that's something I think we will automatically change now when these come in. I'm also going to need to measure the diameter of that. We might have to buy higher voltage just to get it to fit in the clip. So that was a bit of exploratory work. So we'll go to the service manual, which I will find because we've had it out this week. So we'll use the Amstrad manual because it's handy, and we've only got this in the Fidelity with this chassis in it. So they have you start on channel 1 on these. The channel display isn't in the locating peg. Something we'll address. Makes the display look a bit wonky. There's a good word for a Saturday. Let's put the squelch on so that it doesn't annoy us. So we know we can use the chassis as an earth point, which is handy. And it's the far side of this capacitor for the VCO. So we're starting on channel 1, the far side of capacitor 9. I mean, that looks like it's right, but we'll go through the motions of changing it anyway. And we are 2 volts, so we're going to transmit. And we should also have 2 volts. So 2.13. Just the trimmer capacitor. .01 back to receive, 2 volts back to transmit. Totally changed. I think we'll just waggle this round in a circle in case it's got some dust in it. Mind you probably can't see it because that lead's in the way. Even with the ceramic tool, the slightest pressure and we've got a change. Wish I'd not touched it now. There we go, 2.01. So back to receive, 2.02. Back to transmit, 2.6. There we are, 2.05. Back to receive, 2.01. Back to transmit, 2.2. Let's try it at 1.98. Back to receive, on to transmit 2.1. I think we're going to leave it at that. So now we're going to go to channel 40 and just check it's in lock, and we need it to be, it says 4 to 5 volts, but to be honest anything over 3 is quite correct. So once again, check it on receive. Yeah, well that's not right. Oh, I'm on a resistor, I'm not even on the capacitor. 3.2 is fine, and on transmit 3.78 is fine. So that's the VCO checked. So don't do that at home. If it's in lock, I mean where it was fine, but it was just for the demonstration. Let's get rid of the fluff out of the mic. I have a friend who says he used to collect fluff as a little boy. It's a bit dodgy. So we'll go through the transmit and see whether we can make any gains. So we're now at 3.2 watts. Make sure picture in picture's on. And we'll make sure we're on channel 20. That's peak. Peak. Which is soldering iron on ready. Peak. To be honest, it doesn't look like it's ever been touched, but that coil does look like it's been touched. So about 3.3 watts at the moment. We'll use that tool for that. That's fine. And this. Spot on the 4. There we are, we're spot on the 4. Perhaps when this was tuned last time we were on a less tight test set. I think I was on the Farnell one, which isn't as selective as this one. It's not like a Zetagi meter, but it isn't as selective as this one. So there we go. Actually, we could say that's 4.1, but I think we'll just detune that. Okay, so we'll go over to the 10 decibel attenuator, which puts it on low power at the back there. It's supposed to be 0.4 watts. It's no longer a legal requirement. It's doing 0.3 watts. So for those of you who don't know, when CB was introduced in 1981, if your base station area was above 7 meters from local ground level, in other words, if it was more than 21, 22 feet above the ground, then you had to switch your power to 0.4 of a watt. That was the law. But it was because of TVI and problems with the Civil Aviation Authority, but a few years later they took that rule away when things were okay. So that covers that bit of the transmitter. Let's see where the meter is on the radio. Well, it should be in the centre of the red zone. It's now beyond the red zone. This is going to be difficult for you to see as well. There we are, centre of the red zone. Deviation was a little bit low, so we'll just pop that up. Wallow. Spot on. So now, on my piece of paper, we've now got 4 watts, 2.2 to 2.5 kilohertz. Frequency is as close as we're going to get it. Straight onto the receive. Struck me why the power supply was different. When this was made, the UK was on 240 volts mains. Now we're on 230 volts mains. Right, we'll start with the detector. So we're going to put S9 on the test set, put the oscilloscope on and switch off the bench light so we can see it, and switch the camera to that one. And now we'll see whether the detector's in its optimum position. Hang on a minute. That's not the detector, is it, on these? Nearly. It's that one. Wow, that was out. Glad we checked that. So now we'll drop the signal and we'll go over to the cyanide meter and see whether we can get a bit more out of this than the already excellent 2.9 microvolts. So we'll drop the attenuator to about 4 or 5. These will require a bit bigger signal. What we don't want is that tool on the floor. It's a ceramic tiled floor, so everything breaks. That's why I had it done like that. That is actually broken. So we're going to replace it. So that's got overlooked last time round, or because it was one of our sets I just didn't care. So what we'll do, we'll switch off. We'll probably find a scrap fake Amstrad to pinch the part off. We'll just pop a million screws out. Actually there's only 4 on these, that makes them a better ratio in my opinion. Get my bearings. I think we'll unsolder one off a scrap set first. So for a start, this looks, to be honest, it's like a genuine one. It's ridiculous that a genuine Amstrad is in the scrap bin, but there you go. Yeah, that's working fine. Right, hopefully we've got that out in one piece. And that's being glued down, which isn't ideal across there because these glues can change the capacity. I think we've still got some solder on that lower pin. So that can go straight in the bin. And fingers crossed that this one actually works. We won't have that as close to the board, and we won't be gluing it. I'll go over that with isopropyl alcohol if this works. And if it doesn't, we'll be doing it again. Okay, so let's see where we were. That's it. So now we'll look at the cyanide reading, and that could be not quite on the 12, that's 2.6. So between that detector and the Duff coil, which was probably in the same place, the right place anyway, so we've got 0.26 microvolts. For what that's worth, it's that bit of an improvement. So switch it back off again. We'll do the isopropyl alcohol, and I'll take a break while that dries. Okay, I'm back onto this radio. So that's the area where we've put the resistor back in, and as you can see, that has been now soldered around and cleaned up, of course. I don't know whether we can get any closer. There we go. So back to normal position. Well, there's one thing, we know which way around this goes because of its feet, so it doesn't make it a difficult thing to do. I'm going to try and do a 407 perhaps next weekend, and this time we'll have got those power supply parts, and we'll change the capacitors in the power supply, not because it necessarily needs it, but because it's time to do it. Now they're 38 years old. You know, wouldn't you have thought there'd be some base stations on the market, because now with CE multi-norm, you've got a world market apart from America, who still require separate models because of their legislation. But you'd think there was room for base stations. There hasn't been one since that Team 8000 Pro. Not that we've got one of those that works. We've got two here, but both of them are very far from working. But it is a dedicated base station. It's not a mobile board with a power supply like most base stations are. It is dedicated. Having said that, the Fidelity 3000 was dedicated, but it doesn't make it a good set. So, why aren't these that popular? Or the 407s? You know, you see a lot of Murphy base stations which were Reebok Spirit transportable in a big box. And they're a bit of an also-ran, but these are a Cybernet set. But there you are. So we'll put it back on, and we'll look at the squelch. Oh, we'd better look at the meter while we're still doing this. So we've got S9 now. Make sure we've got no picture-in-picture on. So it's showing me plus 30, which of course is now wrong. We've improved the receive a bit. And it's that one there. If you wonder why the sound's going off, it's because it's leaning against the external speaker socket at the back as I tilted it. So we've now got S9 in the correct place, and that leads us to check the squelch out. Now squelch is the letdown on this chassis, so we'll turn that down to a low signal. We'll turn the squelch to full. As I've said many times before, what we'd like, and we'll go to the attenuator control and put picture-in-picture back on. Yes, so we're at full squelch, and I want it to come into 100 microvolts, which is just there. See if we can put the light on the attenuator controls a bit better. So 3, 10, 30, 100. That is where it wants to be. So I must have set it correctly in the first place, and it's the preset just there. So we'll put it back to 0.3 microvolt. We'll put the signal generator to standby, turn the squelch down, and set threshold on the front panel knob. Switch the signal generator on, and let's see when it comes in. It's coming in at 2.6 microvolts. So, it's coming at 0.8 microvolts. Let's do that again. Yeah, 0.8 microvolts, and it's leaving at 0.39. That's the only slight letdown, and not the best squelch in the world, but you know, it's going to work round scratchy corners, so that's what it's all about. So there you go. That's the Harvard 404. I better put the lids on it. And I'll come back to you because I'm going to shove that through the dishwasher. Okay, so the lid's been through the dishwasher and the knobs have been through the dishwasher, and hopefully it's a little bit cleaner than it was. Right, let's see what we can hear. One Anna Roger. Oh, they won't hear me, will they? I've got all that turned down. One Anna Roger. Okay, well, we'll see how that is on the air test. I'm sure it'll work great. And there's something different for today. Hope you enjoyed seeing the Harvard H404 from 1981-1982 era. Thanks for watching.